Okay, so before we do our stat lab session, what we're going to do now is to go back to our lesson for classification in weka as part of our machine learning activities. And for me to rationalize again the concepts, since maybe if you would be honest with me, siguro it really sounded foreign to you, am I right? So, parang foreign yung concept sa inyo. Andyan pa ba kayo?
Yes, Doc.
Yes,
You're here po.
Yeah,
Yes, Doc.
I'm not so sure if the concept was something like, sige, allow recording tayo. I'm not so sure if the concept is something that you can actually appreciate now, but if in case you would be doing it over and over, you would get to appreciate it once you're handling big data and that you're going to provide some analysis that's meaningful for the organization where you're currently working with. So maybe you would be tasked to do some forecasting, you would be tasked to do some classification, predictions, because anyway, predictions are normal, especially if in case you want to anticipate for future scenarios based on current conditions. But please be assured that what you would be learning in machine learning may they be very complicated at hindsight, but if in case you're going to do some applications of it in your dissertation, it would be a lot easier if in case you would have this particular skill set. So this is the intention of having this particular stat lab sessions in my class so that you can have a practical experience on handling this data set. Now, before I begin, I would be forwarding the data set that we're going to handle now. It's a COVID result prediction data set. I'm currently working on this particular data set. The expanded version of this I got from Kaggle. No? So this one is the COVID result prediction I got from Mexico, again from Kaggle. So I'm working on an expanded version of this as part of my bid to publish this in a Scopus Index journal. I found another journal na Scopus and dali lang kaayo ninyo sundan. So it's very it's something that you can actually consider. Sino dito ang hindi pa nakapagpa-approve ng dataset ng kanilang topic? Meron akong mga na-approve. Yung iba hindi lang nag-contact sa akin. Sige, so let's start our session. Okay, sige. Balikan natin ulit yung ating weka, no? So of course, if we review, if you remember, we were able to discuss what the origin and history of weka, ano yung benefits and drawbacks niya, ano yung mga versions niya, and then ano yung mga interfaces niya, how to download it, how to install it, and the compatibility of the files that you can import in the software. Okay, so they have the weka has a lot of interfaces. Now it has 5 interfaces, and the most common is the pinaka-common natin na interface is the Explorer one. Okay, so the Explorer one is basically our playground when we do our analysis. But if in case you go with the highly advanced and automation processes, you might want to go to experimenter and knowledge flow. But that one is reserved for advanced machine learning. We have the basic one, which is Explorer. Okay, so before anything else, kindly confirm in the chat if you were able to receive the classification.xlsx datasets.
Yes po, Doc.
Since we are at it, kindly kindly open your camera na lang so that I can see you doing something in your computer. Remember that since this is a lab session, you're expected to log in your laptop or desktop computer, and then sundan niyo yung proseso ko later. Although you can actually request for recording, like two of your classmates have been doing now. They asked for authorization to record so that they can have something to unsa. But I'm also recording this for the benefit of those who cannot follow. Okay, but I would appreciate if in case you take down notes later para at least something. Okay, so una is we will be again recapitulating our procedures in exporting our dataset. So as you can see, nakatime din ako ang kuan ko. So it includes how to import your dataset. So if in case you have an R file or if in case your data is saved as an R file, it would be easier for you to just import it because the default for R file for weka is an R file. But then what I have given to you is, or what I have given you is an XLSX file, the recent version of a Microsoft Excel file. So we're going to go to weka and try if in case we can export that data set. Ay nagran-run na day po kung ako ang model. So nagran-run kung ako ang model. I found out that so far the most basic and non-optimized is 93.55% classification accuracy when you run it in random forest. So I would also encourage you later to run it in this particular algorithm. Okay, so you open your weka and you can see this particular graphic user interface or the GUI. Okay, so ano ang next natin na gagawin if in case mag-import tayo ng dataset, we're going to click Explorer. So after that, it would give us another window, something like that. And then it would basically give you the blank ones. Now, this Weka Explorer interface allows us to graphically inspect our data set. So we can see their statistics for our attributes, their distribution according to bar graph, something like that. And we can also identify if in case meron tayong mga unique na mga or distinct na mga groupings, or are there any missing data that we have? Now, prior to modeling, you need to actually address issues of the data set itself. So that means that you're going to address issues related to instances. Anong ibig sabihin ng instances? Instances are also known as observations. In case ang ating observations medyo kulang or medyo meron pa tayong problema. So we're going to do a little bit of tweaking using the algorithms available. If in case nga ulit, if in case maalala ninyo, ano nga ang tawag sa machine learning kapag ang punto mo or ang target mo is, checking the completeness of your data set, addressing the issues of your instances and the like. Is it supervised or unsupervised?
Supervised.
Ano po?
Supervised.
Supervised.
Unsupervised.
Unsupervised. Okay. So that's correct. No? Unsupervised machine learning po yun. So it tries to incorporate algorithms in order to address issues of the data set itself without actually doing modeling, because the modeling one is supervised. So, okay. So what we're going to do is we click open file. And then, naka-R file pa ito. So try to check if in case there are Excel or XLSX. Sir, wala man, sir. Something like that. So the closest one to an XLSX file is a CSV file. So what we're going to do is we're going to convert that. We're going to convert that Excel file that we have kanina. Saan ba yun? I think it's not here. Right? So, kadaghan akong data. Ayan, classification data set. So I'm going to convert this one. Nag-choppy ko. Padungog pa ko niya. Dili ako niya madungog?
Madungog, Dok.
Madungog, Dok. Dili ka choppy.
Dili ka choppy, Dok.
Okay. Sige. So this one is in Excel file. Of course, ang gagawin natin is save muna natin siya into a CSV file or a comma comma separated values file. So I'm going to go to file, then tapos save as, and then instead in the file format you select CSV, comma delimited. Kapag naka-Windows kayo, ang piliin ninyo is the usual setting natin, the CSV, comma delimited. So saan natin siya pwede natin i-save, pwede natin gamitin si CSV UTF-8 because this is the old one.
May wifi.
Sa baba, sir, na.
Direct sa-
Okay, sige. Okay. Sige, ang gawin natin is piliin natin si CSV UTF-8 or the comma delimited. In Windows, you select the CSV comma delimited setting. Pwede din gamitin itong specialty formats kapag nasa MacBook kayo. Piliin natin si comma separated values. So whichever, that's basically good. No? So piliin ko na lang ito kasi ito yung common format dito sa MacBook. Afterwards, let's click save. Okay, that's how you convert your data set. But then kapag malaki yung ating data, may possibility kasi that your software would warn you na, or your Excel would warn you that there could be some possible data loss, especially if you want to convert it into a comma separated values. Kasi even in programming, ang comma separated values are not divided by anong tawag dito? Cell. Ang tawag dito, ito ng mga areas, cell ito, cell. This is cell A92, cell C92, something like that. When you save that into a CSV file and then you're going to use that in its true form, yung file na yan, comma separated values yan. So for that line, it would be 68, 2, 2, so comma ang mag-separate sa kanya. No? So you have to be very careful in using amounts or data na nakakama or naka-accounting values. For example, 1,950. So kapag ang ginawa mo is 1,950 yan to represent 1,950, when you save that in CSV file, it would create an additional, in programming, it would split that particular information into two. 1 and 950. So you have to be very careful in saving data sets with comma or accounting versions or accounting values. So you need to convert that into numeric values. Anong ibig sabihin ng accounting? Okay, so in programming, if in case hindi nyo i-pre-process yan, may possibility na kapag magsisave kayo ng values, ng mga values. Let's say this, let's convert this into numeric and to a number. Okay, and let's convert this into accounting. So okay, sa pagganyan, may comma, something like that, or lagyan na lang natin ng comma kasi amount eh. So kapag ganon, kapag ganyan ang interpretation, babasahin ito because a period is okay in a CSV file, which means that this is just considered one character. But if in case this one would be saved in a CSV file and you do some sort of programming, the comma there serves as a separator of two columns. That's why if in case this would be treated, this would be 1 and 950. So careful tayo doon. Okay? So delete lang natin ito and we're going to save this one so that we can start our data pre-processing. So ano ba ang sinabi natin dito sa data pre-processing? We start with importing our data and visualizing feature value distribution and relationships to class values. Ang ating class values, ang ating class variable is our dependent variable in this case. The one that is being predicted, something like that. The one that is being predicted here. Now, after that is we're going to do some pre-processing filters. Now, pre-processing filters includes identifying specific issues about class imbalance, about missing values, about the need for us to convert this into normalized or standardized or discretized, whichever. So we're going to discuss that one by one. Now, so first is we're going to import our data set muna. We go back to our weka software. And then we click open file and then there you have it. So hanapin natin sa downloads. I guess I opened that in downloads. Walang R file, so CSV tayo. So this one is our dataset, the classification.csv. Okay, so afterwards, you import that by clicking open. So it's not recognized as a CSV data files. Reason, wrong number of values. Okay, so there must be something wrong with how I saved it. So balikan ko na lang siya. So if in case successful naman yung importation ninyo, kindly chat in the chat box successful if in case it's successful. So since naka-UTF-8 siya, I'll just select the CSV comma delimited or comma separated values. I'll click save for that and then I'll click replace. Okay. So usong-uso ang problems in data mining in weka na hindi siya babasahin yung ating file. So hindi babasahin ang ating file, and that's fine because basically meron tayong issue in terms of saving the file or converting it to a readable format. Okay, so in that case, it would give you this particular data set. So makikita natin dito na may pagka-bell shape curve ang ating age. No? Kikita ninyo, maraming cases ng mga bata ang nako-COVID kahit wala pa silang 1 year. Okay, so napakarami ito. Bakit kaya? Because they are vulnerable. Then nag-bell-shaped curve siya. That means ang concentration is nasa around 34 years old and up to 70 years. So andyan ang may pinakamaraming cases apart from children. Kasi ito is vulnerable ito eh. Ito yung mga siguro natakdan, something like that. Okay, so that's the age of these respondents. Titingnan natin kung meron tayong missing values. Saan natin makikita kung nasan ang missing values? We can see it here. The selected attribute, we can see that the variable's name is age. We have missing 2. So kapag ganon, pwede ba natin na hayaan na lang yan na magmo-model tayo ng hindi kompleto yung dataset? I mean, if in case you're going to do it, you're basically skipping out specific information na sayang. No? So of course, we're going to try our best for this. We're going to address this particular issue by simply selecting whether or not you're going to do something in order to impute data for those missing values, or just leave it at that because dalawa lang sila. So kung titingnan natin, it is categorized as a numeric variable and the minimum value or age is 0 and the maximum is 115. So may na-COVID pa pala na 115 years old. Isa ang na-COVID na 100, ang age is 112 to 115. Ang exact na age niya is 115. Pero kung titingnan mo dito sa kanyang Gaussian, sa bell-shaped curve, sa normal distribution curve, the bin gives us ranges of values for this. No, it's 112.3 to 6 to 115. What does that mean? That means that this particular bar graph here is not representing a categorical value, but a numeric value. So such numeric values are lumped together as bins. So this one is a bin, this one is a bin, these are bins containing the ranges of numbers that are divided so that we can create a Gaussian distribution or a bell-shaped distribution. Okay, so that's for numeric variables. We go to pregnancy. We have, if in case yung ating respondents are pregnant or not, so we can see here that we have two values, distinct two values. Maybe one is pregnant and 2 is not pregnant. And then diabetes, 1 diabetic, 2 not diabetic. But naka-numeric pa siya. So kapag categorical ito, tas numeric ang reading ni weka, there is a need for us to convert this into the discrete values talaga. And then asthma, then tapos 1 and 2, asthmatic, non-asthmatic, cardiovascular problem, with problem, no problem, may missing value pa rin. And then tobacco, nagatabako ba siya or hindi nagatabako? Tapos when na-contact trace na, meron ba siyang contact, nakuha ba niya ito from others? Yes and no, 1 and 2. And then result, kasi hindi pa daw, no? Hindi pa daw ito totoo na result. Kumbaga, ano ba yung prediction? Na positive or negative? So 1 and 2 pa rin. So naka-numeric lahat ang ating variables, and we are sure that this one is just numeric because this is age distribution based on the distinct number. While pregnancy with 2 values, something like that, could actually be an indication that this is categorical in nature. And kapag categorical in nature, at saka ng numeric sa weka, there is a need for us to use specific filters to do the conversion. So, sir, paano natin gagawin yun? Anong una nating gagawin? Una nating gagawin is we will convert, we have 2 issues here. Missing values and the discrete values turned into numeric values. Pero yung age, numeric value talaga yan. So anong gagawin natin, sir? Una, i-address muna natin ang missing values. Titingnan natin kung ilan ang missing. For COVID result, 3, 5, 2, 1, 4, 2, 0, 2. So ilan ba ang ating number of instances? Ilan ba yung number natin ng respondents? Ang number of respondents natin is 20,352. Big data talaga siya, no? Kasi COVID result good siya. In fact, ang original nito na data set is 536,000. Almost 500,000. So I just trimmed it and then I just got the 20,000 for our analysis. So una is meron tayong issue ng missing values and then meron tayong issue ng discretization. So una, saan dyan ang mas matimbang? Unahin muna natin ang nature ng variable, which is to convert the numeric one into discrete one. So how do we do that? We go to filter by selecting choose or clicking choose. And then we go to filter. And then we go to unsupervised. And then we go to attribute. So in that attribute, we can see a lot of available na mga algorithms. No, you don't need to code them already because it has already been preset. What we're going to do is we're going to just implement what needs to be implemented. And the first one is to convert numeric into nominal. Bakit siya nominal? Because discrete variables are nominal variables. So I would select numeric to nominal here. Okay, that's basically that's basically the step. Just select numeric to nominal, and then in order for me to implement this algorithm to pregnancy to COVID result, what I'm going to do is I'll click this numeric to nominal here, and then meron ditong capabilities. Una is ang kanyang application is application to first to last. That means from age to COVID result. And we're going to basically not do it because in the first place, yung age is not a nominal value. It's really a numeric value. So what I'm going to do here is I would change this one instead of first to second. Because hindi dapat applicable ang algorithm na to for your age. Okay? So I'll try that and then I'll click OK. And then afterwards, kapag na-okay na tayo, click natin apply. Nasundan po ba natin? Okay, so kapag may ganyan, may valid, hindi valid yung range na list at second to last. So that means there's a problem with your algorithm. So we go back to that. Ano nga ulit yun? Pregnancy to try ko ulit, nakalimutan ko na. 2018 pa yun. Let's click OK. And then Uy! Wait. 2, 3, 4, 5, 6, 7, 8. Click. Uy! Wait lang. Bakit hindi siya gumagana? Sandali lang. 2,
Wala, nalagyan kama yung 7.
okay. Sige. 2, 3, 4, 5, 6, 7, 8. Click OK. And then I'll apply. Ay, salamat. So basically, ang gawin nyo, since magiging selective tayo dito sa pag-a-apply ng algorithm, we're going to apply the algorithm only to variable or attribute number 2, 3, 4, 5, 6, 7, and 8. So kapag naging colored na ang dataset ninyo, that only means that you were successful in implementing that algorithm to those attributes. Now, if in case kasi na hindi natin yan isi-set, hindi magiging nominal din si numeric. Diba? So, what if i-undo ko muna, no? Hindi muna natin i-implement yung algorithm, something like that. So, ganyan pa, meron pa siyang problem, no? Kapag kasi na i-apply natin yan, so magiging colored lang ba siya or yung magiging gauge distribution ba yung ating mga variables na in-applyan? Wala tayong ginawa kay variable number 1. So as you can see here, makikita mo na medyo meron ng changes, no? That means naka-discretize na ito. So naging nominal na ang variables na pregnancy, diabetes, asthma, cardiovascular, tobacco, contact other COVID, and COVID result. Okay? So meron ba tayong class imbalance based on this one? Hindi naman masyadong magkakalayo yung kanilang disparity. No? Hindi talaga siya as in overwhelming na nagkakalayo. So of course, there is no indication of class imbalance in here. It's just normal na difference. Anong ibig sabihin ng class imbalance? A good example of class imbalance is if in case your dependent variable looks like that. Pagpalagay natin your class variable is yes or no, bagsak or pasar. So kung gamay lang kaayo ni siya class, ini siya is your 0 and this one is your 1. This is an example of a class imbalance. But then our class variable here looks just fine because meron tayong red at meron tayong blue here. That means that this is just okay. Now, sir, what happened to the numeric variable na in-exempt natin? Na-applyan ba siya ng pagiging nominal? Punta natin si age. Wala namang ganon. But sir, how about kapag nakalimutan po natin iset yung algorithm na ganon? So pagpalagay na lang natin na wala, no? So first to last ang gagawin natin. Click OK. And then let's say we'll apply that. And as you can see here, your age talaga na 104 na unique values naging categorical. So 1 is representing 1, 0 representing 0, 1 representing 1, 2 representing 2. So napakaraming categories. So ang nangyari, hindi siya nakabin. No, wala kasi siyang ranging kasi hindi na numeric ang kanyang reading kundi nominal or a category na. So napakarami yung bins. For pregnancy, ganon. However, this one, nakikita naman natin na may distinct 104 siya na distribution and it would give you the impression na baka hindi ito categories but merely numbers. So ang gagawin natin is to stick with this one and allow the algorithm to apply to pregnancy to COVID result because these are really nominal to begin with. So paano natin malalaman kung nominal or hindi? Kayo ang magde-define yan sa paper ninyo na itong variable na to is age, this is numeric, ito yung kanyang values na ranges. If in case na nominal, it's coded as 1 or 2. What does 1 mean? What does 2 mean? So kayo ang magde-define yan in a specific table. Okay? So again, i-implement natin ulit ang algorithm. We're going to 4, 5, 6, 7, 8. Click okay. So na-solve na natin ang first problem. So we're going to address the second problem which is missing data. So sirs, paano natin yan gagawin? We're going to click the filter and we're going to go to filters and then unsupervised, and then instead of attribute, which is attribute kanina, piliin natin si okay, so kapag ang gusto ninyo is magre-remove po kayo ng mga duplicates, magre-remove po kayo ng mga missing values, dito tayo sa instance. But in this case, we're going to look for the replace missing values. Okay? So attribute and then hanapin natin si replace missing values. Okay? So ang ating replace missing values would apply values to the missing cells, but it depends also on your attribute. If your attribute is numeric like age, it would give you the average of that. No, ang mapuli sa blank na mga cells is ang average sa tanan values nga present. No, na siya ang mapuli. If in case pod na numeric, if in case nominal pod ang wala, ang mapuli diha is the most recurring or the most recurring value of that frequency or mode ang mapuli ana. So replace missing values tayo. Click natin yan. And then we'll check the settings of replace missing values by clicking it. Now, if in case na gusto mo mag-apply, i-apply ninyo ang algorithm sa tanan variables regardless of what variables they are. Are they attributes? Are they class variables? Then you can immediately click this one. But if in case you want to if in case ang problem nato is ang age to contact other COVID lang ang naay missing values, ang COVID result kay kompleto tanan. So if in case gusto ninyo nga dili affected ang atong variable number 8 or ang atong class variable, just go to ignore class and then instead of false, you make this true. That only means that the variable that this particular algorithm will apply to age, pregnancy, diabetes, asthma, cardiovascular, tobacco, and contact other COVID only. Si COVID result will be unaffected. Okay? But since pati si ating COVID result, meron man siyang problem on missing values, ang gawin natin is we'll just select the default one. Okay? And afterwards, we click OK. So all good tayo, and then we're going to click apply. Okay, so kapag na-apply nyo na yung algorithm na yan, check the selected attributes kung meron pa ba tayong missing according here. So meron dito sa age, 0 na ang missing. Si pregnancy, 0 na. Si diabetes, 0. Si asthma, 0. Si cardiovascular, 0. Si tobacco, 0. And si contact other COVID, 0. And si COVID result, 0. Sige, try it daw. Try it. And then questions before tayo mag-proceed.
Doc, may missing 3 sa COVID result.
Ano daw? May missing?
Sa COVID
3
result po.
sa COVID
Okay.
result may
Okay, so meron tayong missing na 3 sa COVID result. Tingnan natin yung ignore class. Bakit ito naka-ignore class? Kandali lang. Replace missing values. We don't... Okay, baliktad ako ang explanation. If in case you wanted to include if in case you wanted to include the COVID result or the class variable, select true instead of false. Kasi kapag false ang nakaset dito, yung COVID result will be ignored na variable. So in this case, tingnan natin, when we set this into true, something like that, when we have set this into true, 0 na yung ating COVID result. So ang gawin natin, i-implement natin yan na algorithm na ang ating ignore class is true, and then afterwards, type in the chat box na okay if in case lahat wala ng missing values. So ano ba ang Sige, ano ba ano ba ang value ng pag-a-apply ng ganitong algorithm in our dataset? This would ensure na wala kang missing values. Missing values is malaking kalaban natin sa ating malaking kalaban ng mga analysts for big data. Pero huwag niyong gamitin ang algorithm na to para punan ang pagkukulang na wala. For example, no, ay kulang, wala ko'y kuan, wala ko'y data sa Davao del Sur na ako'y 100 ka buok na or na ako'y 10 ka buok respondents na wala ing ani ako wala lang gamitag replace missing values uy anaan. Huwag niyong abusuhin ang filter na to.
Para panakip butas ganyan.
Correct. Wag yung gamitin ito para maging panakipbutas sila sa mga wala, no? So of course, this would only apply if in case meron tayong problema sa ating dataset like na mali ba nila og type na or instead of 1 to 5 ang na-type ang nakuan dira ang nabutang is 45, balik gud pag type good. So kana siya klaro na kay na outlier. So i-delete nato na siya and then we replace that with a specific values. Kasi outlier naman talaga yan. So what I'm saying is that in order for you to have a more reliable analysis, you need to remove extreme values and you substitute the deleted values or missing values with the most recurring one or the average of that particular attribute so that your analysis will not be affected. Kung ang naman siya effect sa standard deviation or sa unsa sa ato ang regression or sa correlation, minute ra gid siya kaayo as in infinitesimal value ra gid siya which means nga 0.0005 ana ra gid siguro or 0.002 ana ra gid ang iyang effect. So very negligible gid siya class. Kaysa nga butangan ani mog 45 din ha mo binat gina siya sa imong standard deviations. I have shown you in the past kung unsa gid ang effect sa missing values in that particular setting. So this one is a good algorithm to do the thing. Yes, Jonathan.
In terms of age, is it possible na outlier ning mga above 100 or this is real-time data gyud doc na source?
Correct, no? So that's a very valid question. Una is, di ba, ang age man gyud nato is kuan man gyud no very limited unya na man gyud tay kining numeric nato kining ato ang ages more than the lifespan could be considered as outliers to begin with kay wa maging ana pero kana man gyud siya nga data set is from John Hopkins. That means that that particular ages are real. Ang problema lang is whether or not you're going to treat them as outliers based on their number of occurrences or not. Kasi kung tutuusin, kung titingnan natin si age, at one view, normally distributed naman siya. So kung ako, if in case na I would really stick with something, if in case I want to stick with a really better analysis and a good fit of the model, we could actually delete the instances of that particular respondent with a very high age. Pero sayang din kasi, no? Masayangan kasi ta sa ingana, no? Masayang na mawala ang data for that particular respondent just because napakataas ng value ng kanyang age. Kung tutuusin din, meron din naman tayong 0 years old, napakarami din naman nila, diba? So one way is to just allow it to exist but ensure that there's that particular numeric value is normally distributed. Pangalawa is if in case it really is a violation, you may want to consider deleting that and then replacing it with an average just to handle the analysis or just to make your analysis on a good fit. So you need to strike that decision. You need to decide by striking a balance between those considerations. But tama ka, there could be a possibility that we can omit them. But in this case, we will treat it muna as it is, they are valid, no? Para at least lang na ma-estimate nato siya as a mean. Kasi mean man kasi ang ating i-estimate nito sa kanyang contribution to your COVID result. Kasi probability man ang ating i-compute dito, particularly because we would be computing odds ratio for this in logistic regression. But in this case kasi, since ang age natin is continuous, we would create a classifier or we would do some classification based on mean scores and standard deviation. So nakita nyo na dito na itong pula is the age distribution of COVID negative. I'm sorry, COVID positive. And itong blue is the age distribution of COVID negatives. So, pwede natin i-delete, no? Pero kung tutuusin, ang pag-delete natin yan is magre-require ng additional filter which we can actually address by going to saan naman to? By either standardizing it, no? Para standard yung ating data set, or we can actually create bins, convert this numeric values into categorical variables, or convert them into nominal form. That means itong mga bins na ito is mako-convert siya into ranges, and then it would be considered to be nominal in nature or nominal na. So lahat na siya nominal, wala na tayong mean and standard deviation. Pero in this case, we'll treat it as normal na lang muna kasi yung COVID wala namang pinipiling edad. Ang suspetsya ko kasi may mga data sets kasi depending on scenarios, may mga data sets kasi na siguro mali yung pagkaka-encode or hindi siya standard, hindi siya within the standard. Pero since age has no standard, regardless of 0 to 125 years old ang edad mo, kung umabot ka talaga dyan, let's keep it at that na lang. Okay? Sige, ang gawin natin is kapag na-remove na po natin yung ating mga missing values at saka na-categorize na po natin yung ating mga variables as numeric or nominal, ang gagawin po natin is ready na po tayo sa ating supervised machine learning. Okay, so balikan natin yung slides natin. We were able to address specific algorithms here. Specific issues here using algorithms used for pre-processing. We did some importation, na-visualize naman natin yung ating value distribution. Meron tayong pre-processing na mga filters na in-implement, the conversion of numeric to nominal, and then replace missing values with mean and mode of that. Okay? So after which, okay, ito yung basically yung steps natin, no? So after which, ready na tayo okay na tayo dito. Let's go with the classification. So our classification would be tatlo. Tatlo ba? 5 pala, sorry. So ang ating classification is 5 na lang muna. Wala muna tayong mga hyperparameter tunings na gagawin. Ano yung hyperparameter tunings? Remember last time, meron tayong KNN3, KNN5, KNN7. Wala muna, no? Yung the most default na lang muna yung ating gagamitin, or the most basic na lang muna ng mga algorithms. So how do we apply classification? When do we classify to begin? So magka-classify lang tayo if in case ang ating dependent variable or class variable is a nominal variable. Okay? Anong ibig sabihin ng nominal? It is discrete. It is categorical in nature. So in this case, 0 represents negative COVID finding and 1 represents positive COVID finding. So if that is the case, we would resort to the nonlinear model, which with ang linear kasi is regression, di ba, the ordinary least squares regression analysis. The nonlinear version would be basically the logistic one. So the logistic regression analysis, when you do it in its statistical form, intends to compute odds or likelihood of occurrence or membership to a class in comparison to the linear one, which is meant to estimate an increase or decrease of the mean. Remember katong sa ordinary least square, sa atong simple and multiple linear regression, ang ginabuhat nato ato is when we increase this first independent variable or this independent variable by 1, what is the corresponding increase to the dependent variable? Maalala nyo yon? Plus the constant value, y equals mx plus b. So substitute x with 1 or increase natin ang value ni x by 1, what would happen to your y? So that's basically the ordinary least squares approach, because least squares nga, that means it intends to increase or decrease the mean upon any increase of your independent variable. But for this one, it doesn't do that. It computes for likelihood. No? Ano ba ang likelihood na ikaw ay classified as positive sa COVID or negative sa COVID based on this specific characterization? Okay, so if that's the intention, then classification or doing a classifier is good. So since nakaset na tayo dito na ang ating class variable is the COVID result, then we're going to basically do the classification. But sir, what if sir yung aking class variable is si cardiovascular? How could I set it? So you can actually set it by going to this one and set this as class cardiovascular. So of course, mati-change din ang distribution mo. Pero kung babalikan mo ulit sa COVID result, magiging ganyan na ulit. Okay? Now, we're going to select classify. And then, again, we're going to do some test options here. Ang gagawin natin is, for today, is training set and then cross-validation. Dalawa yung ating iraran ngayon, okay? So first, we're going to select which specific algorithms are common for prediction of a dependent variable with a binary value. So we click choose. Tapos, meron tayong mga classifiers dito na pinaka-common. So unang-una, sa base, so pinaka-common is naive base. Okay, ito yung pinaka-common. So kindly list first as naive base. And then for functions, pinaka-common is logistic. At saka C, simple logistic, or pwede din si multi-layer perceptron if in case you're going to apply neural networks. But in this case, we'll apply under functions, logistic lang muna. Okay? And then for lazy, ang pinaka common is the K nearest neighbor or the LBK algorithm. So we're going to use the K nearest neighbor classifier because it's appropriate to create different partitions at a given K. So ang ating K dito, ating iraran is K n3 na lang muna. Okay, so we're going to set the parameter to 3 as the most basic or the most fundamental na unsa. Ano ka? Nag-record ang naka-on ang ako ang kuan, naka-on ako ang mag-careful lang gid mo ana sa inyo ang mga cellphone kay maminaw na usahay magkuan na siya, mag-recording na siya, mag-transcribe sa inyong voice. So LBK, and then sa rules, wala muna tayo sa rules, punta tayo sa trees. Ang ating trees is, ang pinaka-common is J48. Pinaka-common si J48, and then we'll throw in random forest. So again, ano yung ating algorithm for trees? J48 and random forest. For lazy, it's LBK. For functions, logistic, and for base is naive base. So bakit ganun, sir? Bakit ang dami-dami nating pagpipilian? Because we're going to select which algorithm is suitable to fit or to do the classification. Because that algorithm would be best in predicting this particular data set. And why would we do that? Because comparing model prediction accuracy is common in data science. Okay? So that only means that while naive base would be okay for this, it's not okay for everyone. It could be okay for some other data sets. And this one would provide us a better fit. Something like that. Okay? So ang gagawin natin, we'll select first naive base. And then we'll just allow it. No, all the settings here, we'll just allow it. Click OK. And then we'll run this using the use training set. And then make sure that your class variable is COVID result. This one. And then click start. So we have here 68.83% classification accuracy, meaning to say that those who were classified as negatives plus those who are identified as positives are correctly classified according to what they are in actuality. Kung negative ka sa actual, o ang model nag-predict sa imo nga negative, then that's good. So that indicates na 64.83% lang ang accuracy ng ating model. If in case na ganun ang gagamitin natin for prediction, we can only say, sir, I am not really confident because my model can only predict 64.83%. It's not really sure. Napakalaki ng margin of error mo, no? Napakalaki ng error mo kumbaga. So kung makikita mo 35% good ang imuhang incorrectly classified instances. So maybe even though in actuality, even though in prediction you are classified as negative, but in actuality positive di ay ka. So napaka-dangerous ng ganong assumption. So you cannot risk your decision based on a 65% accuracy ng model mo. Okay, so what about we're going to simulate it by dividing the data set to 10 partitions. So that means i-classify ang maghimo og classification, i-divide na pulo tapos ang classification i-apply sa fold number 1, fold 2, fold 3, fold and up until fold 10, and then i-average ang correctly classified instances kung unsa ang ihang result. So you're going to set cross validation at its default, which is 10, and then click start. So you can see here that the algorithm is evaluating the folds and creating partitions. The average correctly classified instances is 64.81%. Compared with the training set, which is 64.83%, this is a lot more accurate compared to this one, but the difference is a little bit minute. Dili kayo siya. So in that case, naive Bayes, or how do I really pronounce it? Naive Bayes is actually 64.81% to 64.83% accurate in predicting whether or not the variables could contribute to the possibility that the patient is COVID-19 positive or COVID-19 negative. Okay, so please run it for 1 minute. Run the naive malibog siya ko ano eh. Naive Bayes using the use training set as test option and using the cross validation with 10 folds as an option. Before we proceed with selecting another classifier. Sige, questions tayo. Yes, Jonathan.
Oh, sorry to ask again, ha.
No, it's
When you
not
say
wrong to
COVID
ask.
rest,
It's
okay,
not
Doc.
wrong to ask. Continue.
Okay, Doc. When you say COVID rest, Doc, ano gali ulit tong meaning ng data na ito, Doc, yung COVID rest? Maybe hindi ko nakita kuan kanina.
Ang COVID rest is COVID result. Kumbaga, this was the finding for this particular patient. The 0 represents COVID
1 and 2, Doc.
1 and 2. I-check muna natin sa pre-processing, sorry. Ang COVID result, ang 1 is positive, ang 2 is negative.
Ang other COVID, Doc, contact other COVID.
Dalawa lang man ang values. Ay, contact other COVID. Ang 1,
Yes.
ang ibig sabihin, this yes at saka no man ito, no. Ang 1 is nakahawa ba sila, parang sila ba yung parang meron ba silang yung parang yung nag-contact tracing dati na meron kang kasama.
Sila exposure, Doc, na
Sila,
positive
correct, that's
patient.
the term. Correct, that's the term. So they were able to have exposure, ang 1, ang 2 is no exposure. Basically, ang data set na to has metadata, may interpretation. Hindi ko lang na-take note yung meaning ng data ng attributes, no. So if in case you're going to access Kaggle na data set, huwag niyong kalimutan i-take note ang mga meanings ng mga variables na andon. Okay?
Okay, Doc.
Sa tobacco is, ang 1 is smoker, ang 2 is non-smoker. Ang sa cardiovascular is 1 has a cardiovascular disease, 2 has no cardiovascular disease. Itong cardiovascular, yung mga hypertension, high blood, something like that. Ang asthma kay asthmatic, and number 2, non-asthmatic. Ang diabetes, diabetic. Ang number 1, ang number 2 is non-diabetic. Ang pregnancy, ang 1 is buntis. Ang number 2, dili buntis. Tapos yung age, something like that. Okay, ang COVID result, ang 1 is positive. Ang 2 is negative. Okay, so we go with classify. So tapos na kayo mag-run ng naive base classifier for use training set and cross-validation na 10 folds. If in case you're good, we'll proceed to the lazy one. And we'll start with LBK. Now, as I've mentioned, LBA is K nearest neighbor. So what we're going to do is we're going to set this as K3. Okay? K3 siya, hindi siya K1. And then afterwards, we click OK. And afterwards, use training set. Yan na lang muna. And then start running. Toot. So magdagan gid siya no kung number of instances ngayang ma-process. Nari sa baba ang yang prompt, the process 1,200 instances. That means the algorithm is currently scouring in deep sa pattern sa imong dataset in that number of observations. So antayin lang natin siya na matapos. Don't you know na ang isa sa pinakamatagal matapos na classifier is a classifier involving cancers. So it took them 29 days para lumabas yung output. Because the algorithm is really looking, kasi images yun eh. Ang dami-dami ng considerations sa consider mga amino acids, mga specific na mga body chemistry, something like that. Tapos ang imuhang gipang analyze kay cells gid mismo whether this looks cancerous or not. And images yun. So tagal matapos talaga niya. So the model took them 29 days. Ang pinakamatagal ko na run is 9 hours. 9 hours for millions of data set of students who wanted to select a university. So it took me 9 hours. I-restart na kung balik, basig nag-error lang. 9 hours gid siya class. So akong gibukat, giran ako siya, tapos ipasagdan ako siya. So 9 hours ko wala nila ag. Sige ako ana-ana sa mouse para di mapalo. And then nag-load gyud siya finally. So in this case, ang ating KNN3 gave us 67.44% accuracy. Okay? So we're going to run it at cross-validation 10. Click cross-validation 10, and then we'll click start. So it's evaluating the data set, pero the data set is divided into 10 folds. That means the 20,000 is divided into 2,000 plus. So hahanapin pa niya yung fold, ang pattern for fold 1, fold 2 until fold 10. And then i-average niya.
Dok, hulatan lang gid na siya nga mo stop, Dok, no? Thank you. Wa naman siya mo stop, Dok, sa lazy.
So uban paspas po.
Kuan po na siya, paspas na siya, pero magdepende po na sa imong computer.
But
So kung
ako
ang
siguro.
kung i7 pataas na tong computer na pero kani siya kay gina-evaluate naman din sa status nga evaluating fold 1, 2, 3 ana. So in this case kapag okay na, that means nandito na yung ating dataset. Now, part ba sa inyong i-report kung pila ka seconds? Time taken to build the model 0.01 seconds, but ang pag-load niya took us how many seconds, no? In this case, the KNN across validation is 64.34% compared to the training one, which is 67.44, which means that compared that treating the entire data set as a training set could give us higher accuracy rate compared to dividing the data set into different cross-validation folds. Okay, again, let's run another na unsa. So let's run this. Wala man tayo meta boosting buhaton, wala tayong meta boosting.
Atong function pa, Doc. Pa nato na try.
Function is logistic. Okay, so for logistic, okay, click natin yan. Let's just allow it, something like that. And then we're going to set training set and then click start. Yan. Tapos na siya, it's 64%. Now, if in case we're going to divide it into 10 folds, which is mas matagal, click start. So as you can see here, the logistic regression coefficients are distributed for class 1 for this one, no, for your variables given this parameter, given this range parameter settings that we have here. But basically, let's disregard that and just focus in this one. So 64% siya, 64.02%. This one is 64.06%. Very marginal lang ang kanyang, very gamay lang kaayo ang iyang difference. Next, we're going to select trees. Then J48. And then use training set, start 66%. And then let's start with the cross validation. And then it's, yeah. I think this is decision tree. Okay. Now, since this is decision tree, you can actually right click this one. And then visualize tree. So this is the decision tree for COVID. So, ayan. So, pwede mo siya i-expand, something like that. And then let's try to expand this also by visualizing the tree. So, ito yung decision tree for everything. So, kapag ang edad daw is, ang risk factor nito is that kung ang edad mo is less than 30 and kapag more than 30 ang imong edad. So, naanakay specific ranges of age na makonsider na pwede ka ma-positive or pwede ka ma-negative given your specific age. Okay, so afterwards, we'll try the other one, random forest tag. And then use training set and then start. I think random forest works perfectly for this data set. Time to build the model is 10.49. Yan, tumatakbo yung ating data set. Hindi pala, 68% lang din pala siya. Okay, and then we'll try with the cross validation. So I would explain to you how do we improve the accuracy rating of this one? How do we ensure that the model can actually increase to 90%, 95%, something like that. So yan ang magiging catch ng supervised machine learning because you're going to use hyperparameter tunings. That means you're going to increase the number of parameters of from 0.25 to 0.5 to 0.75, if in case you need to increase the number of Ks in the KNN, or you're going to look at the data set in itself. You're going to create or to study the attributes themselves kung saan ba doon ang possibly hindi correlated with this one. And then you remove that variables na medyo hindi talaga nakaka-contribute sa explanation towards your COVID case. No? So in that case, we're going to do some exploratory data analysis after we have run this. Anong ibig sabihin ng exploratory data analysis? That means that we're going to understand the features, whether the features of that data set or whether your independent variables ba are really correlates with your dependent variable. Baka kasi ang ginawa natin sa data set, yung data set na ito, may mga variables pala na hindi pala akma or hindi siya nagmamatter for our dependent variable. So in this case, kadugay mahumani, random forest, 64% ang kanyang accuracy. So after all that has been said and done, nakita natin na ang pinaka-best classifier is random forest, which is 68%.
Lazy.
And yeah, random forest, 68%.
Lazy. 67.
And lazy, 67.44%, KN and 3. But we have confirmed that use training set or hindi tayo magko-cross validation would give us a better fit. So if that's the case, hindi tayo pwede mag-stop lang doon na sasabihin lang natin na, sir, kuan lang man sir, 65% naman ang classification accuracy. We're not going to basically do that. Hindi tayo magsusurrender because ang gagawin natin should be making sure that the variables that you have there are really the variables that you need to predict a specific class variable, which is your COVID result. If that's the case na you want to improve your model, you go to select attributes. Now, we wanted to understand our variables basically, and we wanted to ensure that what we have here are really the variables that matter with COVID results. So we're going to set, after we select the attributes, set muna natin ang ating class variable, which is the COVID result. And then afterwards, what we're going to do is we apply specific evaluators. Okay? So ang ating attribute evaluator na gagamitin are correlation attribute evaluations, infogain attribute evaluations, and the wrapper subset evaluator. So yung tatlong yan, may mga meaning yan dito. Kapag daw wrapper subset evaluation daw, it's intended to ayan, nawala. Ito yung kanyang may mga explanation yan dito. So wrapper, infogain, tapos correlation attribute. So ang correlation, ang mga attribute evaluators na ito ay may mga specific na katugma na mga search methods. Ano ang ibig sabihin nun? Ang ginagawa ng evaluators is kinocompute niya ang possible, kumbaga it's akin to correlation. Ano dito ang mga variables na pwede mong tanggalin kasi wala siyang worth. Hindi siya importante in your classification, and you need to remove them because it affects your classification accuracy. So tatlo ang gagamitin natin na approaches, yung correlation, which requires a ranker search method. Kapag infogain naman, it would require either a ranker, it could be a ranker or greedy stepwise or best first. Kapag pipili ka ng ranker sa maling attribute evaluator, magpo-prompt yung system. Sasabihin niya na since ang infogain ang pinili mo, kailangan na ang piliin mo is CFS. No? Hindi ka pwedeng mag-best fit first. So, kapag best fit kasi is okay siya for CFS na subset, hindi naman CFS ang gagamitin natin. So, ang gagamitin natin is correlation attribute. It requires you to use ranker. So, that means you're going to implement that. And then, use full training set. Nakita natin na ang full training set is better in terms of classification accuracy compared to cross-validation. Although sometimes you need to do cross-validation for consistency purposes. So let's start. nakita natin na ang dito, according to correlation attribute evaluator, nakita natin na ito ang order of importance ng mga variables in predicting COVID result. Age is a possible correlate because ang kanya is 0.2022 ang kanyang weight, followed by your diabetes, cardiovascular, pregnancy, contact over COVID, tobacco, and asthma. So may possibility na si asthma pwede nating tanggalin so that your model will improve. Okay? Next one is pipili tayo ng another one, Infogain. Tapos, check natin kung hindi pwede. No. So Infogain, Ranker, and then click Start. So in this case also, age, diabetes, cardiovascular, pregnancy, contact other COVID, tobacco, asthma. So almost of the same rank here with your Infogain. Or yung ating correlation attribute evaluator. So medyo same din sila ng ranking. And then we'll select wrapper, and wrapper is utilizing greedy stepwise algorithm. We click yes, and then we'll click start. Tingnan natin kung ano ang mga variables na pwede nating tanggalin. So according sa greedy stepwise, ang nakita niya na possible folds para mas accurate is 5. So, saan mo yan makikita? Dito yan. So, sinabi niya na dapat i-divide mo daw yung dataset mo into 5 cross-validation folds para makita mo yung accuracy. Ang gagawin natin, let's follow that and we'll implement 5 and click start. So, ngayon, sinabi niya sa atin na wag mong i-divide sa 10. I-divide mo lang sa 5 para mas okay. Okay? So, nakita natin dito na, again, ang ranking is age pa rin. Age, pregnancy, diabetes, asthma, cardiovascular, tobacco, and ang last now is contact other COVID cases. Si tobacco palaging second to the last. So, may possibility na ang based on this, asthma seems to be questionable based on two evaluations na ating ginawa. So may possibility na pwede nating tanggalin si asthma at saka si tobacco. So let's try removing that data set or that particular something. I-remove natin si asthma at saka si tobacco. Titingnan natin kung mag-i-improve ba ang ating classification. Okay? So, i-remove natin yan by clicking them and then remove. And then, puntang ulit tayo sa classify. And then, after sa classify, puntang ulit tayo sa use training set. Tapos, run muna natin si naive base. Tapos, later, kung mag-run na tayo ng cross-validation, hindi na 10, kundi 5 cross-validations na. So, click start. For naive base na hindi pa na-trim, 64.83%. Nung na-trim na siya, it's 64.79%. So, konti lang ang kanyang binaba. What about if in case we do the cross-validation version? 5, click start. It's 64.83%. So, it is a lot higher compared when we divide the data set to 10 in the cross-validation, and a lot higher, or it's a lot, medyo higher lang, a little bit higher compared when we run the entire model with the variables intact. So we can actually say that those variables that we have removed could have contributed less in the prediction of your COVID result, kumbaga. So if that's the case, we will be running cross-validation folds 5 from now on, because according to our exploratory data analysis, the greedy stepwise plus wrapper subset evaluator, 5 lang ang kailangan mo na folds for the most accurate na prediction. Okay, so we'll run the KNN3. We go to lazy. LBK, KNN3, click OK. We'll start with the training set. Okay, still processing. May pa ka nauna. Nauna na. Ako ang computer hindi kaya. So, ilan ang percentage according to your finding? It's
64.8.
66 mo nakuha.
66.63%. So, KNN3. Let's start with cross-validation 5. 5 na ang cross-validation, ha? Let's start.
Na-cross validation ko pala yung kanina.
Okay, okay. Well, use training set muna para at least makita mo yung original niya na percentage. And then afterwards, cross-validation. So, okay. So, after we run this, I would give you 30 minutes to work on logistic, use training set, and cross-validation 5. J48 or the decision tree, use training set and cross-validation 5. And then, same pa rin, random forest, use training set and cross-validation 5. And try to compare from the original data set na hindi natin tinanggalan ng dalawang variables kung nag-improve ba ang kaniyang prediction or hindi siya nag. Okay, questions tayo before I give you the rest of the time to do the data crunching. So this one is 64.82. Yes.
Pwede ba na mauna natin perform yung select attributes before sa classify ba para malaman natin kung ilang folds ng cross validation?
Okay, so that's a very good question. In fact, you'll start with in the real world, in the real application, you'll start with that. Ang ginawa natin is from the very beginning kasi is we don't want to, kasi kung unang-una kung ang mga attributes mo pala are backed up by related literature, sinabi niya na ito ay importante in predicting COVID, why would you remove them? Why would you discard them in the first place if they are actually in your data set? So ang ginawa ko muna talaga na approach is the traditional one, which is running the classifier. And when nakita ko na hindi pala mag-fit yung classifier mo, doon ko ginamit ang selection of your attributes in order for me to trim down the variables that were found to have very, very small weights in predicting your class variable or your COVID result. But then, in most cases, when you will be handling a lot of attributes, let's say ang imong independent variables, millions ang imong data set, and then ang imong variables are, let's say, more than 25, something like that. And you wanted to ensure that you will just be handling the correct number of attributes in the prediction process, then that's the time that you would start pre-processing by doing exploratory data analysis. EDA would basically tell us that these particular independent variables or attributes that you have should be eliminated or should be or it would also give you an idea kung ilan ba ang optimum na folds. Kasi man ang folds, kalima bahin-bahin, kakita mo ginaon sa pag-prepare ang croissant, kana ganing French bread. Kapila na siya piluon na siya, flat, piluon na siya so that you can gain the correct quality. In the same manner, we need to divide randomly the data set into different folds and run the analysis in each fold so that we can actually say na consistent ang finding mo from fold 1 to fold 5. That means that when you run it in the overall analysis, it is also true in every partitions. Hindi man siya parehas talaga ng result, but basically, the same lang gid, halos no 64%, 63.78%, halos comparable lang ang iyang fit. However, again, you need to also you also need to consider that not everything in your data set is true in the prediction. So it's important that when you have those variables with you and you are not sure, sir, kanus man mi dapat maguna sa select attributes in fin case ing ana. If you are not sure whether the variables in your data set prove you a purpose, then you start with EDA first, which is this one. So that you will now have a basis in deleting which of these variables are not serving you the purpose in the prediction before you proceed with classification. So tama yun na question. No? That's a very valid question. That's a question that has been asked for quite some time by 3 batches of data analytics. Kasi they don't want na, kumbaga sa kanila is, they were able to handle big data before. Pagpalagay natin sa isang supermarket, may mga data, may mga attribute columns daw doon na parang hindi nagme-make sense sa kanila pero matakot sila na tanggalin sa analysis. Eh baka importante daw yun. For example, barcode. So may relevance sa barcode's prediction. So para daw meron silang empirical evidence in the removal of the attributes that do not serve them the purpose. Then they resorted to this one, which is actually very good. But then, what if, in a social science research perspective, na tanan independent variables are kanaganing imong gitest kanang atong naandan gani sa atong thesis nga ang tanan independent variables nga imong gibutang dinha sa imong correlation or prediction are all related with your dependent variable unless you have tested its significance in terms of p-value. Di ba ang kanang mga variables nga atong gipamutang sa conceptual framework are assumed to be correlates. So when you assume that they correlated, that means that kahit wala pa tay empirical evidence through statistics, correlated good na siya. Apan, ang katong correlation nga na-establish nato ato nga mga unsa ato sa atong related literature is the finding or are the findings of previous studies that came before us. What we need to do is just to set or just to test it in our context kung true ba gyud ang correlation nga na-establish niya diri. So if that's the case na ang imuhang approach is more of a social science perspective, that what you have included in your data set is known to be correlate, then that's fine. You can actually just proceed to classification after you do the pre-processing. But if you are not sure, if in case you wanted to have, if in case you have a hunch, if in case you wanted to really be certain with your data set na hindi mo alam kung whether it is established by literature or not, then EDA is a very good approach. You need to do that prior to the classification for you to save time. So tama yun. Okay, did I make sense, everyone?
Yes, no.
Okay. So for sure sa inyo daghan kayo mong nakita nga data set sa Kaggle, no? So you might want to try. No? You might want to try running EDA for that. Makita man nato, no? So makita nato kung sa mga number of attributes kinsa man ang naka-download og data set na nga nakita ninyo nga naamoy more than 15 ka attributes. Naka-download na ba ko? Kung naamoy 15, unsa daw, Jem?
Wala pa na kumarando. Pero
Ila man to
ang data set doc na siya 3 files. Ang first file and third file is at balance. Yung second file is the balance.
So, pwede ka mamili ato kung sa imuhang kung gusto na ba ka dito sa balance, na class balance na data set or gusto ba ka atong
okay.
pwede
So
makamamili.
yung balance na lang.
O kung ano ba ang magiging benefit if you do the class balance? Kung dito na ka sa balance na gyud nga data set, ang mahitabo kasi ana is di na ka mo gamit og ingani nga kuan algorithm. Sa naman to. Class balance. Nasa naman to si class balance? It's kadilit lang. No, itong tawag doon. Balance. So na ganito, nalibog naman ko. Dito tayo sa supervised instance. Ito. Supervised machine learning siya, class balancer under instance. Sa class balancer, i-balance niya ang imuhang dependent variable na very layo kaayo ang difference, no? So it would create an artificial sampling. Pero kung gusto ka mag-artificial sampling, good mismo, dili lang class balancer imong buhaton, you go to asa naman to? S man to. S. Instance. S. Hindi siya madali lang class ha, nalimot. 2018 naman ko nagtulog data mining. nawa naman sa ako ang kuan, nawa na siya sa akong pangaghap. Smooth filtering man to siya, smooth. Kulay smooth. Pangitaon lang nako to siya. Nato siya smooth filtering dili. Ang smooth filter is ginagamit siya para mag-increase sa imong sample. So kini siya ang isa pud sa pinakadakong krimen natong mga data scientists kanang mag-smooth filter ta. So unsa nang smooth filter? Naa kay dependent variable nga ing ani, something like that. Gusto sa nimo nga mabalansi ang imuhang mag-class balance ka. Ibutang nato Jim no na ang imuhang 1,000 ka data. 900 ana COVID negative, 100 COVID positive. Klaro gid kay na siya class imbalance, no? Kay 9:1 good. So ang buhaton nato ana is i-make sure nato na ang 100 nga COVID positive mahimo pong 900. Okay, nagets ninyo? So 900 na daan ang negative, 100 ang positive, which means madungagan dapat ang ato ang COVID positive into additional 800 para magpantay siya kay class balance man siya. Pero dili lang manggod class variable ang ato ang ginadungagan. We also need together with the artificial increase of your data set from 100 ka positive into 900 positive, that means magdagdag tag data na additional 800. If that is the case, we also need to increase the number of instances for our attributes. So, unsaon man na nimo, sir? So, ang algorithm mismo ang mo-compute nga kini ibutang nato sa madungag na 800, kini yang sex, kini yang age, ing ani. So we call it artificial resampling. So ang data nato na 1,000, 1,800 na siya. Yung sa man ni mo, sir, nag-smooth filter ka. Ino to nawa, matong smooth diri. Uy, nakalimot naman ko. Asa naman to siya dapita. Nana siya diri sa... limot mo ko smooth mo ang pangalan. Resample daw. Unsa man yung resample? Produces a random subsample of a dataset using either sampling with replacement or without replacement. Mauni siya. So for example, di na siya smooth ang pangalan niya. If in case ang imong buhaton is ang imong class variable nga 1, gusto nimo dungagan nimo og additional how many percent? From 100 mahimo siyang 800. No, pila man ka percent? From 100 to unsa? Kasi ang additional 100%, that means ang 100 mahimong 200, no? Kung may 100%. What if dungagan nimo siyang additional 800. So instead of sample size percent, ang idungag nimo ana 800. That means 8 times madungagan ang imuhang 100, madungagan 800 para mahimo siyang 900. So ang imuhang class variable coded as 1, which is positive na 100 lang, mahimo na siyang 900. So next week we're going to tackle the unsupervised machine learning that includes the things in the pre-processing that we have identified, cluster and associate, including artificial resampling. Pero malihog ko sa inyo ha, ayaw mo pagbuhat sa krimen sa inyong dissertation nga mag-artificial resampling mo nga kapuyan ako mag-survey, uy ako lang ni artificial resampling akong 300 into 1,000. Ayaw ha, kay ang inyong goodness of fit ang madaot ana. Ginabuhat lang nato ng artificial resampling as one of the recourse in order to address class imbalance. But it's never an avenue for you to create an artificial data set that doesn't exist in the first place. Okay, so buhaton nato na siya pero sa ethical nga way. Mura gud po mag-chat GPT ta but in a nice way.
Tama.
So, na yung tanong sa ko, sir, nagagamit ng ChatGPT? Yes, of course. Bakit hindi? No? Pero, sir, hindi magsulat kang research na ChatGPT ka? Of course, yes. Especially if wala ko kabalo kung unsa ang sequencing sa related literature nga akong buhaton. It's really helpful for us, especially kung dili gyud ka researcher. It would give you kuan if you have a problem on about your topic, you ask ChatGPT about possible sequences of related literature na imong buhaton, it would really give you that. No? So ChatGPT is a gem. It's a marvel brought about by artificial intelligence and data science. It's utilizing predictive analytics. And ma-imagine ninyo ang predictions niya in terms of text, the quality of its predictions based on given online parameters. It's really, really amazing and it's really scary at the same time. But it's really, really helpful to you as PhD students. Ayaw lang good mo og answer sa inyong essay or summative assessment using ChatGPT responses because ma-detect man gud na. But I mean, if in case you wanted to have like pareha sa akong gi-require sa inyohan na maghimo mo og article, na gusto ninyo makita kung unsa ang mga specific studies before, or gusto niyo makita ang sequences sa mga ideas sa pagsulat ninyo sa inyong problem, sa inyong dataset, it's really a good thing. However, you just need to retweak, no? You have to restate, paraphrase, and really contextualize your discussions para naman at least na meron kayo talagang ginawa na human intervention. Ganun lang naman yun. Kaya ngayong klase ko, hindi ako masyadong nagpapa-exam na essay type kasi ganun yung magiging scenario eh. May mga students talaga na hindi naman sinasabi na PhD students. May undergrad students talaga na they feel that okay lang na mag-ingana. Although a lot of announcements, so huwag kayong mag-answer ng ChatGPT, something like that because nadidetect ko yan. Meron akong AI language detector na specific software na i-subscribe. Tigas man ang ulo, di zero. Pero ngayon, since practical man ang aking exams kasi parehas nito, stat or analytics, at least makita niyo siya na hindi niyo talaga siya magagamit. Pero if in case susulat kayo ng summative assessment like article and you don't know how to start kasi most of us, good to be honest, are hindi pa talaga seasoned researchers. No? In fact, siguro majority of you here have not really published in a journal. If not everyone. So if in case na wala pa kayong experience sa ganon, I would really appreciate that you start it with my class so that when you go to other classes na in the future, hindi na bago sa inyo yun. Kumbaga, it would be easy for you. You would be guided on what to do, and at the same time, alam niyo na kung paano gamitin yung mga software na pinaka-iilag-ilagan natin. Okay, so do you have any questions with our laboratory session now? From pre-processing, classification, and selecting attributes, you can still raise it now. So i-upload ko to, i-upload ko ito na tutorial sa ating ayan. Para masundan niyo siya, i-upload ko sa ating UVE, save ko muna siya, ha. Sige, Jillian.
Good day, Doc. Good morning po. Ask lang ko sa schedule next week, Doc. Online, face-to-face.
Kanusta gani? Kanusta gani ang next week gani?
May 6 po, Doc, sa calendar.
May 6 sa calendar. Okay. Kay May 6 man siya. So,
First Saturday.
First Saturday. Okay. So, I would not be around for a face-to-face session. Kalang ha.
Karga na ka, Doc.
Yeah.
Ingat po, Doc.
Wala ko May 6 up to May 20. So, wala. Di ka makita sa 6 o sa 20. So, online. May 6, I would give you free time lang siguro anong May 6. I would be posting instead a tutorial, especially 6, 13, and 20 gig class wala ko, no? So if in case I would just make an announcement whether we are okay with online class on those dates. Dili pa nako di ko confident mo ingon nga uy kanang unsa magklase ta ana chuchuchu kay magklase ko kay himuon mo kong tour guide ana sa Netherlands ug sa Italy sa akong boss. So wag ko mabuhat ana no kay wata kabalo at ang mga panahon nga magklase unta ta something like that. Siguro I would give you free time. Kung dili ta makaklase ha, kasi probability pa man ni siya. Kung dili ta makaklase, I would announce that you're going to focus on your paper. Maybe we can set that time for consultation. No, mingon ba kung oy free ko karong Saturday kay magkuan lang ni nara ko sa hotel ana something like that. Okay, mag-schedule ta on what Philippine Standard Time ta mag consultation by groups para makapag-consultation ta regarding sa inyong paper nga gina-work no para sa inyong mga topic or sa inyong data set something like that just to compensate for the time na mawala gid ko kay to be honest Jude unpredictable gid ang mahimo na mga schedule kay 20 makabalik naman noon ni anak class 20 pud noon sa alas 3 sa udto ko maabot og Davao. And you imagine it's jet lag and ngarag, so medyo kailangan ko din magpahinga for that. Pero kung makaya na ako on a Sunday, that's on 21, to compensate for that lost time, I would give you a reschedule. Ay sayangan yun kung di ta magklase nga daghan kay tag apason pa. Tuduan pa ta mo og forecasting sa Arima using Gretel. Unya magtuon pa ta og systems of equations using kuan seemingly unrelated regression or SUR katong akong gigamit sa akong masters using Gretel. Unya sayang kay nga di na ko ni siya itudlo sa inyo ha. Na at least makabalo mo unsaon pag-predict og multiple equations, multiple dependent variables using systems of equations. Tudloan ta mo ana. Siyempre dili ta mo pwede nga dito mo matudloan ana kay what if na interesado sa inyo mag-forecasting sa inyong dissertation, di ba? At least kibalo mo. And of course, we would be ending our session with how to do artificial neural network. Tudloan pud ta mo ana sa SPSS para makabalo gid pud mo unsaon pag-interpret ang mga hidden layers and everything. Kay naabayay predictive analytics ba ang SPSS wala gid siya kay ginagamit and that's the use of artificial neural network and multi-layer perceptron neural analysis. So gamito nato na siya kay para makabaw gid pud mo kay para if in case mag-dissertation mo it would not be very difficult for you to do some adjustments. So I'll save this one and yeah. Okay, anak ka. Weka tutorial April 29. Select. Okay. Downloads, grant access. Okay, so i-save na ko ni, ibutan na ko ni sa UVE para na mo masundan. And then naapod tay ko naapod tay recordings. Ako na pong ibutang sa atong Google Drive. Okay, so nawala imong net. Doc, normal lang na maglahi ang result nato. Especially for cross-validation. Normal siya yun. No? Mapansin ninyo nga, sir, lahi-lagi akong cross-validation because random ang pag-divide sa inyong dataset. No? So, gi-divide ang dataset og napulo na random kung unsa nga instance. So, normally, lahi-lahi yun na siya ang labas anak. Pero dili po siya layo yun kaya sa katanan. Bubutan natin 64.79%. Imo is 64.70%. So, di yun kaya siya as in a very huge ang difference. But it's normal. Paano natin malaman if tama yung nilagay na value para sa ano ito, Jim? Paano natin malaman if tama yung nilagay na value?
Yung kanina yan dong di ba mag-replace na of values with the missing one.
Correct. Sige, correct. Mabuti ni-raise mo yan. Una is kapag numeric ang variable tapos mag-replace missing values, ang algorithm na mismo ang mo-compute sa existing na mga dataset sa mean score. Mean score ang yang ibutang anak sa tanang missing values. Pero kung nominal ang imuhang attributes, tan-aw na niya unsa ang pinakadaghan. Let's say yes or no, ang pinakadaghan yes. So the algorithm would assume that ang ibutang sa missing values for nominal variables are 1 or yes. Okay, blank man siya, so let's assume that it's a yes. Something like that. Kanang wala man ko'y emotion ng algorithm, no? Nga mayon kag kaluoy kaluoy nino. Sino na po na itong ibutang diri, no? Hindi ganyan. Kung ano ang pinakamarami, yung talaga ang kanyang ilalagay. No, but sir, what if sir ang missing values kay kuan pantay lang? Yes or no, 48, 48 na ay missing value na duha. So random po na siya. It could be nga ang ibutang diha is yes or it could be no. Basta random ang algorithm mo hatag ana sa inyo. Pero kung numeric, again, it's the average value. Okay, Jillian. Jillian, you're raising your hand.
Sorry, Doc, nakamute ko. So example sa numeric, Doc, clarify lang ako sa iyang algorithm sa pag-replace of value. Kung na 3 kabuk missing values that to Doc. Example, the mean score is 49.5. Sa tulo kabuk 49.5 po ba iyang ibutang? Tama ba?
Correct.
Okay, thank you, Doc.
So ang mean tanan ang yang ibutang. Kung kuan pod, napoy possibility nga kung imong gamiton is replace missing values with constant. Kung unsa ang constant lyric, maura gud gihapon. Usually ana kanang unsa so ang pinaka safe is replace missing values lang gyud kasi kung nominal ang pinakadaghan ay ang ibutang, ang mode ang iyang ibutang, if in case nga numeric ang mean ang iyang. Okay? So yun din ang limitations ng dataset mo kasi hindi natin malalaman kung ang mean score is truly the representation of that missing values. That's one of the limitations of your unsa. But nevertheless, it's a scientific process to do it because we don't want to largely distort your mean and your modes when you do the prediction. And that's normal for prediction or that's normal for handling big data. Kailangan nating maging conservative din sometimes, no? Let's assume na for the record na kini siya is mean score lang atong ibutang ani sa existing. So that ang purpose nato is we don't want to distort our data set. So if in case you want to read how it's done, how it's discussed, you can visit my name in Google Scholar and look for my 2023 na publication about loan prediction, yung supervised and unsupervised machine learning in predicting loan default. So na-added to ang per section na discussion sa smooth filtering or sa resampling, sa missing value, sa transformation, discretization, and everything. So meron lang kayong idea kung paano siya. Okay? So if in case wala na, it's lunchtime. Thank you very much for coming. Before we end our class, can I request everyone to open their camera?